Okay, so we are finishing lesson 1.1 notes, which, like I said, you guys told me that you worked with the sub yesterday to finish them, but let's do them together. So what is the first definition here for when it's, or the first, word for this definition? The union of A and B is union. Okay, did you all draw a Venn diagram of that yesterday? Okay, so see, this is why I want to do it. So we have a union. So union is denoted with this lovely U symbol. Okay, it's the set combining all elements of the given sets. So if I was to draw a Venn diagram of that, let's start with our rectangle here. Kind of screechy. I took up a little too much space. So we need two circles in there, A and B. And we're going to put that U in there that includes our universal set. So this is A union B, we would say. I'll put that over there. And we would shade the area that we're talking about. So A union B, we would shade all of this. All right, for the next one, the intersection of A and B is, the definition is intersection, right? All right. Okay, so we have intersection, and it's the upside down U. So let's look at a Venn diagram there. Because the union, right, is combining all the elements, which is why we shaded everything in our Venn diagram here. The intersection is the set containing elements common to both sets. So we only want to shade the part that they have in common. I'm really sorry for that screeching noise. So what part is in common? The middle part, the part that's intersecting or overlapping. So when you're showing an intersection, it doesn't want to let me shade that. You shade the part that intersects or is overlapping. All right, and the last one is complement. Have you ever heard the term complement before? Yeah. In math?
Well, we had that in homework.
In your homework? Okay. How about a complementary angle?
Yes, I've heard of it before. I don't remember.
Okay. So the complement of A, all right, is going to be denoted as A prime. It's got that apostrophe up there. Okay, is a complement. So it's the set of all elements in the universal set, but not in set A. So it's like the rest of everything. So in our Venn diagram, we may only have, we only have one circle, okay? And inside there is A, and then our universal. And the part that we're going to shade is everything outside the circle. The complement is everything outside. So this is A prime. Okay, is everything outside.
So would a complement angle be, wouldn't that be like an angle to it's just a variable with that?
Well, so like the reason I ask, complementary angles are two angles that sum to be 90. So if you have an angle that's 30, its complementary angle is 60. If you have an angle that's 50, its complementary angle is 40. Okay, so in this case, the complement is just like if you have A, the complement is everything else to get you to the total or to get the whole universal set. So good question. All right.
What else is there?
Yeah. It's kind of asking what else is there. That's a good way to think about it. One other note here to make is that these first two problems, and I have it on the side of my paper, but I can't like scoot that over. I can scoot over this way a little bit. So make a little side note here that these are binary operations. Binary, B-I-N-A-R-Y. They're binary because they use two sets. There's a set A and a set B, okay, in this. Potentially they can use more than two, yes, but the complement, however, only has set A, so it's called a unary. U-N-A-R-Y. Unary operation. Because it's one set. So hopefully you've got yours to fit on your paper where it's not so overlapping. We have to endure a little bit. Do you prefer the color on the paper or me writing with pencil? No, with me taking notes.
I like it.
You like it? Okay.
I like that a little bit better, but the screeching kind of makes it not.
I know. I've tried to fix it. I'll have to find another possible solution. Okay. So, let's go on to the rest of it. So let's do some examples. Why did it not clear my... There it goes. Okay. So let's look at some examples. All right. So examples 3 says if R, set R is 1, 2, 3, and 4, set S is 1, 3, 5, 7, and U stands for the universal set, is X such that X is a single-digit natural number. Whew. Find the result of each set operation. All right, so first of all, let's break down this first one, this U. Let's make a list of those. What are those numbers? Okay, do you guys agree that it's 1 through 9? I like it. I like it. Lucas, what do you think? Yeah? Okay, let's do it. It is 1 through 9. Okay, so 1, 2, 3, 4, 6, 7, 8, 9. It's barely going to fit on my screen there. Okay, so that's going to help us. So now we need to find the result of each set operation. What's this first one? R union S. What does union mean?
Everything that's together.
You put everything together. You sure about that?
Yep.
Yes, it is. Okay, so R union S equals set. Well, R's got 1, 2, 3, 4. S has 1, 3, 5, 7.
So 1, 2, 3, 4, 5, 7.
1, 2, 3, 4, 5, 7. And close your set. Nicely done. Okay, B says R intersection S. What's the intersection? Okay, but what's intersection mean? Like what they both have in common. So R and S both have a 3 in common and a 1 in common. Okay, I knew you said 2 numbers, Tori. Thank you. I just didn't get them. So our intersection is set 1 and 3. All right, R prime, this is that, or complement. Sorry if I say prime sometimes. That is another way to term it. So R prime equals what set?
5 through 9.
Okay, why 5 through 9?
Because it already has 1, 2, 3.
Ah, yes. Okay, because R prime, or R complement, is the rest of our universals. Right, here are universals, so we have to use those. So R complement is the rest of the universals that aren't included in R. So it's going to be 5, 6, 7, 8, 9. Awesome. Any questions? Okay, then let's look at example 4. I'm going to move us up again here. So use R, S, and U. Oh, I can't move us up. I forgot. Dang it. From example 3. I just don't have quite enough room to record and do it. Okay, so use R, S, and U from example 3. Find each set and draw a Venn diagram illustrating the operations. Okay. And we already had our answers there, so that would have been helpful. So let's go back to the R complement at least and write that one back up. You said it was 5, 7, 8. Okay, so we have that to reference. Okay, so when we're doing R complement intersection S, okay, we want to draw our Venn diagram. So what two things are going to be in our Venn diagram?
The 1 and the 3. Oh no, that's going to be the intersection part of the diagram. You're going to need a box for the union and 2 circles, one for R and one for S.
Okay,
Wait,
so
is it
let's.
normal R or is it complementary?
It's complementary R.
Oh, I didn't see that.
Right, so that's okay.
So you put. Oh, you do complementary R circle, which would be 5 through 9, and then you do an S circle, and then S is 5 and 7 would be in the middle.
Okay. Say that again.
I don't know how to speak pictures.
For R.
Okay, let's do it.
5, 6, 7, 8, and 9 for the set of R. Then the intersection
Mm-hmm.
with S, which that's 1, 3, 5, and 7.
Okay.
Which the intersection of both of them would be 5 and 7.
Okay, so. Whoop, that was messed up, but it's easier to just. Okay, so you're saying the set for the intersection is 5 and 7. Okay, because our complement was right here, 5, 6, 7, 8, and 9. And S is 1, 3, 5, 7. The intersection is what they have in common, so they both have a 5 and a 7. I'm repeating this so much because we're recording it for Lauren. Okay, so all right, make sure we're good with that. Good. So it is 5 and 7. So then how are we going to show that here? It sometimes helps if we do like an intermediate step here, or at least for me. So hopefully it'll help you understand. So our complement would be, we would shade everything besides R. Okay, so this is our complement. It really is. I know, I'm so sorry. All right, so then what would, so our, I'm trying really hard not to make that sound. Okay, so where would our R complement intersection S be shaded?
Only on the intersection? No, only on the S side.
Only on the S side. So this stuff in here?
Yep.
Yep, you got it. Did the intermediate step help? You see? Okay, good. It helps me visualize it a lot. So this is our complement intersection S. That's the Venn diagram for that. Because where our complement intersects S is just inside the S. But for me to to think about it and process it, I have to have that intermediate step. Otherwise,
all of S or not including 5 and 7?
5 and 7 is including with R, so you wouldn't shade that in since that's part of R.
well, so
all of them are part of R. That's why we shaded it. R.
You don't shade it
no,
R.
R is not part of 5 and 7, right?
Oh.
Like 5 and 7 is part of S.
I'm meaning R complement.
R complement. Do we need to put some numbers in there? Like we can write the numbers in if that would make sense too. Like R is 1, 2, 3, and 4. And so let's see. 1 and 3 goes in the middle, right? And then 2 and 4 of R goes over here. And then S is 5 and 7. I tried to write those at the same time. So since 5 and 7 is where our set 5 and 7 is where we should be shading, we only shaded this part over here that shows the 5 and 7. Does that answer your question? Okay, fantastic. All right, so now let's look at B, which is, notice the parentheses are inside the complement. So we need to find the R intersection S and then the complement of that. Wouldn't it be everything except for 1 and 3? Yes. So let's break that down as well. Okay, I have to get down here and write. Okay, so when we look at this, what is R intersection S?
1 and 3.
Okay, so R intersection S is the set 1 and 3. So yeah, then R intersection S prime is everything else. So what are those numbers?
2, 4, 5, 6, 7, 8, 9.
I don't think there's a 10. No, there's no 10. Just goes to 9 because it's the single digit numbers.
Yeah, kind of confusing.
That's okay. All right. So again, if we look, let's do an intermediate Venn diagram. So let's do R intersection S first. So here's my R. Here's S, my universal. The intersection is what part? The inner side. Excellent. That overlaps. So this is R intersection S. So now let's do, we're going to cut it off a little bit, overlap my numbers. R, S, my universal. So how are we going to do R intersection S complement? What would we shade?
Shade everything besides.
Excellent. So we're going to shade everything besides that little sliver in the middle.
Which now it just looks like you missed a spot.
Now it does just look like I missed a spot. Maybe I need to go over it in a different color. Be like, this is, oh, didn't switch my color. This section is not shaded. Not very good, but that section's not shaded. Okay. All right, how you feeling about that then? Perfect. Okay, then your homework for tonight in section 1.1 is number 7, 13, 17, 19, 27 through 30, 37 through 38, 42, 43, 46 through 48, and 50. Again, that's in section 1.1, so you're going back a lesson.